Alright, last example of completing the square, number 3. Now in number 3, if you notice, it is actually a factorable quadratic equation. So by factoring method, x equals 8 and x equals 1 are actually both the solution of this equation. But let's just say we want to solve by completing the square. So separate the variables and the constant into the left hand side and the right hand side. So I'm going to move the constant 8 to the right. Left hand side, I'm left with just x squared minus 9x. And I'm going to leave some space here because my leading coefficient is already the invisible positive 1, equal negative 8. As usual, we want to make sure that we add the value of this special equation, b over 2 squared, to both sides. But hey, we know r lowercase b is negative 9. So b over 2 squared, if I were to do it on top, actually no, I'm doing it next here. This actually equals to negative 9 over 2 squared. But that's going to give us positive 81. Positive 81 over 4. So we want to add positive 81 over 4 to both sides and keep everything else. Right. Now let's try to factor the left hand side. Well, the left hand side is again a standard form quadratic equation with the leading coefficient of positive 1. So same way of thinking as in my other videos. Look at the first term, look at the last term, and look at the second coefficient. The multiplicative factor of the first term, x squared, is just x and x. Now for the third term, I want to come up with two real numbers that multiply together to give me back positive 81 over 4, but also added together to give me back the second coefficient, negative 9. Well, I realized that 81 over 4 is the value of the b over 2 squared that I did on top. So maybe I'm going to try this factor, negative 9 over 2 times negative 9 over 2. And of course, it's obvious because we did it earlier too. Negative 9 over 2 times negative 9 over 2 is 81 over 4. Again. But are these two multiplicative factors, when added together, going to give me back negative 9? So I got negative 9 over 2 plus negative 9 over 2, which is negative 9 over 2 minus negative 9 over 2. Keeping the common denominator 2, adding the numerators, I'm going to get negative 18. Since I have negative 18 over 2, that turns out to be negative 9. Well, hey, that is the second coefficient I'm looking for. So, negative 9 over 2 and negative 9 over 2 go into these two empty spots. What about the right-hand side? Well, the right-hand side, I got negative 8 plus 81 over 4. Any number by itself is the same as itself divided by positive 1. So because we're adding any two fractions, because we're adding a whole number with the fractions, it is better to write that whole number into its fractional form. So looking at the smaller denominator and comparing it to the larger denominator, the smaller denominator, positive 1, is one of the multiplicative factors of the larger one. So I can convert the smaller one to the larger by simply multiplying it to positive 4. But then I had to repeat the same thing for the numerator. So that means this thing is going to turn into negative 32 over 4 plus 81 over 4. Keeping the common denominator 4. 81 subtract 32, that's actually going to give me 49. Okay, so guess what? On the left hand side, two identical binomial factors multiplying together means that binomial factor itself raised to the second power equal 49 over 4. We want to solve for x, so we have to get rid of the second exponent and the minus 9 over 2 by taking the square root, by first taking the square root of both sides to take away the second exponent. So left hand side we're left with x minus 9 over 2. Right hand side, because we only have division underneath the square root, the loss of exponent allows us to separate the exponent into two distinct ones. One goes with the numerator and one goes with the denominator. But then we know that the right hand side is going to be plus or minus because we're taking the square root. Square root of 49 is going to give us 7. Square root of 4 is going to give us 2. And then x minus 9 over 2 on the left stays the same. Now we want to solve for x, so we can add 9 over 2 to both sides. Now with the plus and the minus, there are going to be two cases. Case 1 is going to be x equal positive 7 over 2 plus 9 over 2. And that's going to give us 16 over 2, which is positive 8. And the second case is going to be x equal negative 7 over 2 plus 9 over 2, which is going to give us, let's see, 2 over 2, which is positive 1. Well, hey, we check it, I mentally checked it earlier too, that x equals 8 and x equals 1 are actually the solution of this equation. So if you guys would like to check it, just go ahead and take each of these x value, plug it back into the equation, and make sure the left hand side is either the same or different than the right hand side. If they are the same, that means that x value that you plug in is the solution. If the x value you plug in makes the left hand side different than the right hand side, meaning they are not equal, then that means that x value is the extraneous solution.